Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 11th grade topic, trig transformation visuals. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page, @TutorMeSenpai, and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have two parts, so leave a like, smash subscribe, and let's get started! Previously, I made a video covering specific trig transformations, namely changes in amplitude and how it affects the graph, and your changes in frequency and period and how that affects the graph. In that video, we also talked about how you can find your amplitude, period, and your frequency based off of your general trig formula. If you missed that video, no worries, you can find it right up here. However, I have to admit, in that video, there was a lack of visuals to drive the points home. Now, we did have some, but not a lot. And I know some people are more visual learners, so I want to come back and dedicate a video just showing the visuals, comparing our basic trig functions to these transformations, and we see how they look at the same time. I want to really focus on that today. But not only are we going to cover your changes in amplitude and your changes in period and frequency, we're going to be looking at the two transformations that we did not cover in that previous video. And that's going to be your phase shifts and your vertical shifts. And we're going to use a free online calculator to display everything today. The calculator I'm going to be using today, I'll be putting in the description box below. I'll also link another calculator that is a little bit simpler to use, but definitely not as fancy. So without further ado, let's jump into our calculator. So for today's visuals, I'll be focusing mainly on the sine function, but feel free to try out cosine. It works the same exact way, but I'm going to be mainly looking at sine today. And we're going to see how each transformation is going to affect our basic trig function, at the same time comparing it to the original that's still going to be on screen. So what you see here are actually two basic sine functions, a red one and a bluish purple one. And they have a regular amplitude, a regular frequency. There's no phase shifts, no vertical shifts. It's just a basic sine function. So let's first look at changes in amplitude. Now remember, all of these are going to be based off of our general trig formula. The one for sine was a times sine of, in parentheses, b times x plus c, close parentheses, plus d. And we're going to be changing that a because a is going to control our amplitude. So if we go to this sign right here and we change it from 1, remember our amplitude of 1 is going to make this 1. We did it from 1 to, let's say, 2. We see that our blue graph, our blue sign, now immediately jumps up to a height of 2. And we see that it also goes down to -2. So we have new highs and new lows. When we have a whole number jump up, we're going to be stretching our basic sine function. And you can get even bigger. So instead of 2, let's say it went to 3. So now by zooming out a little bit, we see we go all the way up to 3. Our original is at 1, but when we have 3 in front of sine, we're going to go all the way up to 3. So this is going to be a 1-to-1 correlation. As we change this, this is going to change exactly the same amount. But notice this does not change the period. We're still going from 0 to 2 pi. We're still going from 0 to 2 pi. Nothing else is changing about the period. We're just stretching this vertically up to our high and down to our low. But remember, we can also shrink this. We don't have to go up to whole numbers. We can actually put a fraction or a decimal in front. And if we chose to put, let's say, 0.5, we now have a new high, but it's actually a little bit lower than our original. Instead of going all the way up to 1, you see that we're having a max of 0.5. And our minimum is actually going to be a -0.5. So whatever this is, that's going to be your height. And the negative will be your depth, how low you're going to go. So that's going to be our changes in amplitude. It doesn't really matter what this is. You can make it 100. As long as you zoom out enough, is really far. All you're doing is changing the height. So it doesn't matter what you put here, that's going to be your new height. Remember, the amplitude is the absolute value of whatever this is. So you just go up that high and go down that much, and that's going to be your new amplitude. So let's put this back to our original sign. Let's go back to our 0 to 2 pi, and let's look at changes in frequency or period. So notice, both of them go from 0 to 2 pi. This is basic. And we said that that B is going to control our period and our frequency. And by changing this, let's say we upped it to 2, instead of going from 0 to 2 pi in one cycle, now we're going to go from 0 to pi in one cycle. One cycle brings you all the way to pi. Now, the original, if you see this red, it keeps going, right? So it's oscillating a little bit slower than if we put that 2 there. This right here is one full rotation around the unit circle. This is one oscillation. Our new period is pi. So before it repeats itself, as you see, it's repeating itself again, we're gonna have to go the full length of pi. So you can see by simply upping this, you're going to get something that oscillates faster and faster and faster, and you're just going to have a lot of oscillations for that same range of 0 to 2 pi. But just like amplitude, you can also put a fraction or a decimal here, and that will have the opposite effect. So instead of oscillating very fast, we will oscillate pretty slow. So originally we went from 0 to 2 pi, right? Our red goes from 0 to 2 pi, but now you notice that this blue, it only does half as much at 2 pi. When we put a half there, we only went half as much. We're going to zoom in to see the full period. Now the full period is going to be at 4 pi. So from 0 to 4 pi, we do one full oscillation. Our new period is 4 pi. Our original now oscillates twice as fast as our new graph. And you can get even smaller. So instead of 0.5, you can say 0.25. And now we're not even getting the full thing at 4 pi. Our oscillation still hasn't completed here. We got to zoom out a little bit more, and we're seeing we're not actually finishing or completing that oscillation until we get to 8 pi now. And by that time, we've oscillated 1, 2, 3, and 4 full times from our original sine graph. So as this gets closer to 0, you're going to oscillate much slower. And as it gets further away from 0, you're going to oscillate much quicker. This is oscillating so fast that it actually looks like you just drew a rectangle here. So let's reset our graphs and go back to 0 to 2 pi, because now we want to see what happens when we do some phase shifts. Now phase shifts are going to be honestly just moving left to right, just like this. Moving left to right, except not me moving it like this. You're actually going to be able to control that by the C value from our general trig formula. Remember, it's plus C. So if I say plus 1 here, now you see our original graph is a little off from our new graph. And it doesn't matter if you add or subtract. You're still going to be shifting. So it's going to be, oh, I messed up something right here. X minus 1 now. We shift the other way. Minus 2. Plus 3, we're just shifting left and right. That's all we're doing. This is very similar to how you normally shift your regular functions. So this is how your phase shifts will be working. And if you shift it enough, you will line right back up with your original. So let's say we did 6.3. That's pretty on the line there. But once again, you're just going left and right. So let's prime this again. Let's set this back to our basic. And let's wrap this up with our vertical shifts. Now, just like our phase shifts, we're going left to right. Our vertical shifts will be shifting, except this time up and down. And it's going to be a 1-to-1. So as you have sine of x and you add 1, well, now everything got shifted up 1. You're not stretching the graph. So yeah, you do have a new high of 2, but your low is now no longer -1, but 0. So whatever this number is here, that's how high you're moving up the graph. Up 2, up 3, up 4, up 10. You're just shifting the entire graph up that much. And you can do the same thing down. So negative 10, negative 5. It's the same thing. All you're doing is shifting it up and down. You're not changing the period. You're not doing any left or right. You're not changing the amplitude. Yes, you do have new max and new mins, but that's because you shifted the entire graph up and down. So this is going to be your vertical shift. So I hope you were able to follow along in today's video, and I hope you found the visuals helpful. However, if you have any questions about what we saw today, or even on homework, you can always put it in the comment box below, or visit my Facebook page at Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Senpai.